Hey everyone, so in the last video we went over these Docker networking modes and I said I was going to focus a lot on the bridge networking mode, so that's what we're going to do today. So just to kind of recap, when we talk about the bridge mode, the first benefit to using it is that it's really easy. It's actually the default mode, so if you spin up a container with the docker run command that we went over previously, if you don't specify the network, it's going to go to the default bridge network, which is good from a standpoint of just making things work, but there are some downfalls to that. The reason I say there's downfalls is that you can create a user-defined bridge network. And basically the benefit of this is kind of twofold. One of those, actually threefold for that matter. One of those is that you get access to auto DNS. And I'm going to demonstrate that, but in a nutshell, it basically allows you to reach container to container via the name of the container, which is almost like an auto-created DNS entry. It's really cool. So I'll show you guys how that works. Another benefit is if I have a container on the default bridge network, I can't kind of hot plug it or unplug it. I have to actually destroy the container and recreate it if I want to change its network. That's certainly not ideal. If I have a user-defined bridge network, however, I can absolutely disconnect it from a network and reconnect it to a different one as long as we're talking about user-defined networks. So being able to move things around and kind of play with them will definitely be an advantage if you go with the user-defined route. Finally, the last benefit to using the bridge network option, specifically the user-defined one, is that, well, it's more secure. With all of the containers by default being assigned to that default bridge network, well, if you spin up a container and you have, say, an app that starts doing really well, and you spin up another container, it's automatically on the same network. So that's certainly not ideal. So just keep that in mind. I don't think it's a huge issue. However, you should be aware of it because it could potentially be a security challenge. So let's get into it. I'm done with these slides. I want to show you guys how this works. So the first thing I'm going to show you guys is how to create networks, how to verify that the networks are created. So I'm going to be coming back to this slide and I'll be referring to this kind of as a reference point. So I'm going to leave this open right here. I'll make that a little bigger. And I'm going to pull up my terminal so we can get right into Docker. So first, I'm running Docker Desktop as I kind of showed you guys before. So if you haven't seen how to set it up, I have another video. I'll drop a link right here so you guys can see how I set up Docker Desktop. It's very simple. So that's what I'm using right now. So the first thing we're going to do is take a look using Docker PS at our current running containers. And I want you guys to focus on these because these are the ones that I've created for testing. So I have Web A, Web B, Web Y, and Web Z. And those are the ones I really want you to focus on. So the first thing we're going to do is we're going to look at the networks we have available. So to do that, I'm going to do Docker network, and I'll just show you guys some of the available commands. I'm going to hit enter. So you see right here, I get Docker network and then it wants a command. And as far as the commands go, they're pretty straightforward. Connect, I can create a network. I can disconnect a container from a network. Inspect is basically I want to get the details about that network. Things like what container is attached to it, what subnet is it using, when was it created, all of those details. LS is to actually list the networks, which is what we're going to do. So let me show you guys that. I'll do LS. That sounds good. And we see we have some networks here. And you'll see right off the bat, the network types are also known as the driver type. And the driver type for the default network, the name is bridge and the type is bridge. This is the one that is the default that is with Docker. As soon as you spin it up, even if you are following along, you should have this one. You'll also see the host network. So we're not going to focus on that for this video, but that's there by default. There can only be one of those. Then you see I have a couple of user-created ones. They're both of type bridge. And I have one named Mike's-NW for network, and then I have my-net with 2 T's. Let's say we want to go ahead and you see here, I want to create a network. So to do that, I'm going to do Docker network create. I'm going to hit enter so you can see the syntax. So it's asking me for any options that I might want to add, and that would be things like the subnet. So you see here, I'll move this down here. If I wanted to specify the subnet for that network, I can do that there. And the reason I would do this is because that's the subnet that it's actually going to hand out IPs from to your containers. Now keep in mind, the bridge mode means we're going to NAT basically from whatever that range is to whatever the host is using that you're exiting out of. So it's not really a big deal. It's not like this range is going to be exposed to the outside world per se, but it is worth mentioning. So in my case, I'm just going to say Docker network create. I'm going to say nerdy-nw for network. I'm going to hit enter. All right, so we got that ID back, so that looks good. We're going to confirm that with Docker network ls. And we see right here, And as mentioned, if you don't specify the type of network, the default type is bridge network. So I didn't have to specify that, although I could. So nerdy network is created. Now let me inspect it. I want to show you guys Docker network inspect. And in this case, all I need to do is specify a network. So I can specify any of those networks, and this will give me details on it. So in my case, I'm going to up arrow. I'll do nerdy-network. And we just want to look at what the default configuration is. So looking right at the top here, we have the name. We have that ID it generated. We see when it was created, the type of driver, in this case bridge. Now if we go down here, you see that it has this subnet. Now if I create a subnet, it's going to pull an IP from that range, and that will be the container IP. So, and we're going to go through this, so don't worry. Now let's take a look at our containers again. So I've already created these, and I've already assigned these to networks. Let's say I'm going to do a Docker inspect web A. So I'm going to look at this container and just see what the network it looks like. What's it created as or configured as? So in this case, I see that it has a network ID right here, and the gateway is 15.15.01, and the IP assigned to this is 15.15.02, and that's because I gave it this 15 subnet and just for testing. So in my case, I'm good with that. Now let's check out web B. And you'll see here web B has got the next IP in line, so all is well. Now remember that thing I said about auto DNS? Let me show you. And guys, be prepared. This is really cool. If you're a nerd, this is super cool. So I'm going to go ahead and execute a command on one of those containers. So just to kind of remember the names, I'm going to execute that. I'm going to do docker exec-it for an interactive terminal. I'm going to specify the container name. And in this case, I'm going to specify a command to give the container. If this was something like an Ubuntu image, I could do something like bash or bin/bash, and it would basically drop me into a shell in that container. In this case, because of the image I'm using, the shell is actually called ash. It's an Alpine container. That's actually the name of the image. So I'm going to type ash. So it drops us into the container itself. Just to prove that I'm there, if I do an ifconfig, you see here I have that 15.15.0.2. So I am definitely in web A. Now that auto DNS thing that I was talking about, watch this. I'm going to try first to ping web B, just normal ping, nothing fancy here, and of course I can ping it. Now here's where I was talking about auto DNS. I ping the name of the container, and it's working absolutely flawlessly, and I did nothing to make this work. This is considered auto DNS, and this is applicable if you have a user-defined bridge network. Just to illustrate my point, now let's kind of look at the other end of the spectrum. I created this web Y and web Z containers respectively. Now let's hop into those. First, actually, let's take a look at the networks that they're on. So I'm going to do docker inspect. We'll do web Y. And we're going to do things a little differently here. You see it has this network ID. So we'll see if that's useful. And we've got this IP, 172.17.0.1. So I want to see what network that's on. So we're going to do docker network inspect, and we'll specify that ID. So I went through that really fast, so let me just show you guys what I did. So first I did this docker network, oops, not inspect. I inspected the container, and I took the network ID. Now I only did this because I honestly don't remember what network this is on, so it'll be easier for me to find it by referencing this network ID. This is just an identifier for that network, that's all. So then I did docker inspect, and in this case I did, I did docker network inspect, and then I just specified that network ID. By doing that, what that did is that actually kind of spit out the configuration for that network, and most importantly, it's showing me what containers are connected to that network. In this case, I have WebZ and WebY, and we see the IPs respectively. Keep in mind, this is actually the default bridge network, and you can see that right here. The name is bridge. That's just the default. That's not the type. So again, going back to our docker ps command, I'm going to execute a command. I'll do docker exec, same command I did before, except in this case, I'm going to do weby. I'm going to do the ash, and I just want to make sure I got the IPs. So I'm going into weby. So I want to ping, this is going to be, I'm going to make sure I ping this. All right. So there we are, I'm into weby. Now, remember that auto DNS thing we talked about? It should work now, right? Wrong. It doesn't work because I'm on the default bridge network. But just to prove that I do have reachability, if I enter the IP address of WebZ, I'll ping it all day long. So now that I've showed you guys how to assign networks to these containers, the last piece is just making sure that they have reachability outside. What I told you before was that containers would get an IP automatically and that they would have their networks automatically NATed or bridged over to whatever the host is using, and they would be able to talk to the outside world. So let's check that. So I'm going to do docker ps, and to validate this point, by the way, regardless of whether it's a user-defined bridge network or it's just a default bridge network, it works the same. So I'm just going to pick WebA just to make this easy. I'm going to get a terminal back into it. And I'll do an ifconfig just to validate the configuration. So it's got this IP. Now this one definitely would have issues if it was actually being exposed to the outside world, because this is actually a public IP. It's not a private IP or not part of the RFC. So in this case, I'm going to, I'll just ping 888. So we see here, it works all day long. So this container has access to the outside world without any issues. Very little configuration. You guys saw pretty much all of the configuration here. The only thing I didn't actually show you was assigning that network as part of the initial container creation, which is actually really simple. So to do that, let's say I want to start a new container. I'm going to do docker run, I'll name it nerdy web, or I'll do nerdy Linux, LNX. I'm going to name this, well, let's see, let me think about this. I'll put this on my-net. Actually, I'll do this on that nerdy network. There we go. I'm going to do IT for interactive terminal, and I'm going to keep it running, and then I'm going to do Alpine for the image again. So that should be good. So that looks good. If I do a docker ps, I should still see it running. And there it is. So now if we were to do that same exec command to that container, we can actually I can actually show you guys, instead of getting right into the container, I can actually feed this command right to it. So I'll do ping, and you see here basically what I did is, instead of getting a shell into the container, I didn't actually need to do that. I just passed the command instead of going into the ash shell. I just passed it a ping 888 command, and it serves the same function. So that container is talking to the world. Everything is fine. It's up and running. So really simple, really straightforward. Hopefully this was helpful for you guys. Not much to it. In the next video, I'm going to go over the host mode a little bit, and then we should be able to pretty much wrap up Docker networking, and we'll get into Kubernetes.